Coming in live from Louisiana, we have Eddie Flat Earth Banjo here. He's calling in from Japan. How are you today, Eddie?
Great, I'm doing fine, man. It's a beautiful day here in Japan.
Awesome. Well, glad to finally have a conversation with you today, and I think you are going to try to convince me that the circling sun around the flat Earth. We both agree that the Earth is flat. Yes.
That's right.
Okay, so what we may not agree on is the circling sun is the thing. So that's what we are here to talk about. I don't know if we will have time for any other conversations, but we'll start with that, right?
That's great, and as we talked a little bit before, I would love to come back so we can talk other points, other subjects, anything on the table. But today, I really want to cover this circling sun, and I think I have evidences that the sun circles around the flat Earth.
Okay. And in your opinion, the circling sun, is that a physical object to you?
Well, that's no, I don't think the sun is physical, but that's another conversation. You
Okay,
know,
okay.
that would
No
be
worry.
another one because I don't know what the sun is. I can't. I have no idea. I know that it's a light in the sky. That's all I can tell.
Okay, but you believe that there's one object up in the sky that you and I can both observe, correct? That is,
Yes, yes. There are
that.
two luminaries, the moon and the sun. And
Mhm.
so there's this luminary there we can observe passes from east to west here. I can go outside and see now what it
Mhm.
is, and anything else besides looking at the sun, I can't tell you what it is or anything like
Yeah.
that.
Yeah, and one more question I would have is that so in your circling sun, it is always between the Tropic of Cancer and Tropic of Capricorn, correct? Between those two.
Yeah, I
Uh,
would say
uh,
so.
uh,
Yes, I believe it
okay,
is.
okay, okay. So go ahead. The floor is yours, Eddie. You go ahead and give us the presentation, and then I will try to follow as much as I can.
So I don't know. You should know this is a polar projection. So you see, there are no continents here. But this is, you can either go 180 to halves, 180 or 360. Okay. Now this is where I am right here. Right. This is where I
Okay.
am. I don't have continents here. But what I say is that we have a polar projection is based on the magnetic mountain or something that is in the center of this flat Earth. Okay. We need it for
Hmm.
navigation. Without this magnet orientation here, we wouldn't be able to navigate over, the flat Earth. As a matter of fact, this is a Portuguese map back from 1500s, early 1500s. The Portuguese, they became, seafarers back in the 1400s. And this is a map that they were already mapping the plane back in the 1500s, all right, based on the North Pole. That's how they navigated. Once they made use of the compass, up to the 1400s, they were only navigating by the stars locally, not too far away. But once they apply the magnetic compass to their navigation skills, they were able to, I don't know if you know, but the Portuguese were the first ones who really went all over the plane. All right. Vasco da Gama around Africa, and then they reached Asia. And as a matter of fact, Nachi, I have another presentation I have gave. They had mapped Australia in the 1500s. Right, the Portuguese had mapped the east coast of Australia, and they found Timor Leste in 1505, Tristan da Cunha in 1506. They had not only mapped, but with the right coordinates. So this is all based on the compass. So if you can, please play that short video. I just sent you the link.
Okay.
The compass is king who reigns over all arbiters of truth, which measure reality and conclude the objective facts within. Compass derives all geometric outcomes, any plane curve of trajectory or closed curve from 2 points. The compass makes a complete pass around the fixed point. It is determining your position and angle in combination with the sextant and square when drafting, aka cartography, and creating a map, all based on the stars and a single point in the center. Time, location. This should actually be held this way. So that's the true way for this map. This map that is to scale, because if it wasn't to scale, the time chart wouldn't work. The time chart works, which means it's to scale. Weird. What a strange coincidence. That's why our system for navigating is called polar plane coordination. There is a fixed source in the center. Navigation is not possible whatsoever any other way. This is a magnetic compass. It makes a complete pass around a fixed magnet. The compass is the only objective, constant truth in existence. A compass derives all geometric outcomes, any plane curve of trajectory, and closed curve from 2 points. It computes your position, angle of symmetric shapes. The polar plane coordinate system exists because of a fixed center point Polaris, a sextant, and a compass. Your longitude and latitudes are measured by those instruments. There are 24 hours in a day. There are 24 segments to the polar coordinate system. Weird. What a strange coincidence. Each one of these segments is 15 degrees. The stars revolve around Polaris 15 degrees per hour. 24 15-degree segments equals 360 degrees. That's one circle, which consists of 21,600 minutes and 1,296,000 seconds. Navigation is based on this time created by nature's clock. Nature's clock swings east to west just like a normal clock. It turns clockwise. That's why we have right hand rule in Cartesian coordinates. Spherical coordination is not possible until you convert the polar plane coordinates from the fixed point in the center. Every line of longitude is a perfect north-south. There is no other way to navigate or use a compass. The heading indicator inside of an airplane, which is a gyroscopic compass, is not equivalent to a magnetic compass and the arbiter of truth. It is not an arbitration of truth. It is subjective. There are magnets used on the compass. What happens when you put magnets on a compass? It's no longer a compass. That information is manipulated. It's not constant like a magnetic needle compass. The true north for a pilot is the 180-degree mark on the polar plane coordinate system. It's the only way that navigation works. That's why there are 24 segments of 15 degrees that are divided up into minutes and seconds determined by your sextant and your compass. Every longitude is a perfect north-south. No matter where you are on this map, north is up. So that means no matter where you are on this map, which means no matter where you are on this map, which means we know it functions and it has proper scale because this works. And this is based on the stars, which this is based on. It all goes together. There's no other way about it. The only constant of true Earth reality is light. The only constant objective fact made by man is the red half needle of a compass.
All right, so you can see this is the image that I had. I don't need to have any coordinates here. We know for navigation, we need this polar projection, which is based on a center magnetic mountain, which I believe is a mountain. but let's say I don't know what, but we it's all based on this center pole. All right, so that's how we navigate around this uh, desert. All right. So before we move on to the stars, do you think you understand clearly this point, Nachi?
Yep, yep, yeah. I am in agreement with this presentation so far. So, yeah.
All right. Okay, so let's move on. So this is the land where we are. So let's move now to the stars. Just a quick more thing. This is north, and everywhere opposite from north is south. All right. This is an old map by forgot the name of the guy. This is my route when I travel to Brazil. I go around the North Pole. I can either go from Japan, I go Los Angeles and Brazil, or I can go through Europe, same way, come back, always around. I carry my compass with me, so when I'm flying, I carry my compass. I can, pretty much what the guy said. He's the compass master on TikTok. Now let's look at the stars. Okay, this is a star trail taken from Canada. You can see by the vegetation here. Where I am right now in Japan, I can see Polaris. I'm facing south right now. As I talk to you, I'm facing south, darting to my back, east here, west here. And if I position my P900, I can get this from where I am. And I actually have a very interesting image here. These are four um, time lapse of the stars rotating around the Polaris. The Polaris, one from Africa, one from New Mexico, U.S., another one from Hawaii, and this one from Beijing. Right, all pointed to the same star, and that's how we get those time lapses. Right. So, would you be in agreement with me, Nachi, that the stars rotate around the center pole, the center star called Polaris?
Yeah, I would agree with you that the stars are rotating around Polaris. Whether that is right above the North Pole or not, I'm not entirely sure on. But yes, I'm in
Yeah.
agreement that the stars are rotating around Polaris.
Okay. So we can be off a little bit, but we all understand there is this. For navigation, we need this magnetic point, and for navigation, looking at the stars, we need Polaris. So I think they are. I don't know if they are directly, as you said, but this is another view of the constellations are made of those stars, correct, that are rotating. All right. So they select a few of them. They say, okay, that looks like an animal. They call them constellations. So that's what we see. Whether you can look at individual stars like this, right? Or you can select a few and say, okay, this is a constellation, blah, blah, blah. Okay. So this is another time lapse of rotating stars. All right. So, okay, that's great. You agree with me. The first point, we need a compass to navigate on this flat land. And we also look at the stars and we can see they all rotate from east to west. Okay, so let's now get into the sun. All right, let's see what the sun does. Just in case if you don't, yeah, I was thinking, I don't know if he's going to agree or not, but this is a very old Mongolian map which shows the constellations, and they had different names, right, for the constellations. Uh, the Chinese, this is a Japanese actually, right? This is the Japanese, very old, showing the equator up to the North Pole, and the constellations, they have their own names in Japanese. And we have also, this is very interesting. So this is Japanese, the old Japanese language. It's indistinguishable from Chinese. They're very. I have a book from 1800s written in Japanese. They can't. People today cannot read. They say, well, it looks a lot like Chinese. So the Japanese believe, this is Mount Meru, right? And this is very old, Nachi. I went to a temple here in Japan, 1600 years old temple, Buddhist temple. And if you go to Kyoto, where they have a temple there that is just as old, they also have some maps there depicting the same drawing here. Okay, they have the center pole. I mean, not the center pole, not the star, but the Mount Meru. All right, and this mountain for the Japanese is located in this center pole where we were talking just in the beginning. Okay, when this is the polar projection, and for the Japanese, this is where it is located. All right. Now you probably know that the Japanese they really like to play with mechanics and robotics since since I don't know for how long. Okay, so this is a very old from the Edo era painting of the Japanese Mount Sumeru or Mount Meru right here. Okay. Now you see this thing here.
Yes, yes, I'm seeing it.
All right. So this is it's like a clock. Okay. This is a mechanic. Now I'm going to show you. This is a model they don't have in display anymore, but this is a more modern model. And this is another one. Okay. You see the Mount Meru and you see this gear here. Okay. So they have this for something. They had this. Are you familiar with those festivals, Japanese festivals around, Obon, for example, Obon? Are you familiar
No,
with
not
those
really.
festivals?
I mean, I wouldn't say that I'm familiar with it at all. No.
Okay, so they have this festival in August where they celebrate the spirits, and I took part of one a long time ago, and it's pretty nice. You just dance around this place here. Okay, not only sometimes they play drums in there, but not all the time. So this is pretty much in reference to this uh, rock right here in the middle. Okay, this rock, which they call Mount Sumeru, Mount Meru. I think you lived in India for some time. They have the same thing. Now, I showed you about that gear, right? So this is another very old Japanese model. Now, that gear, Nachi, is for these two things here. It's for the sun and the moon. Okay, they had the Japanese. They had physical models of their model of the flat Earth in every temple until this guy arrived here in 1850 something. Okay, today in Masonic history, Matthew Cabret Perry, he arrived here in Japan and bombed the two cities, and that's how heliocentrism arrived in Japan. Right, in 1852, Perry headed to Japan. And so there's a whole story about it. He bombed two cities and he made his way to see the governor. And he was a member of the Lodge Number 8 in New York City. So that's how heliocentrism arrived in Japan. And they physically destroyed those models in those Shinto or Buddhist temples. Now, there are only 5 of them remaining from that area, actually. And they have it like you need to get special permissions in museums to be able to see them. All right. So now that we have covered our flat plane here, have you ever heard the expression the sun enters a constellation? Let's say here the sun enters Cancer. Have you heard this before?
I, no, I mean, I haven't heard that expression. Sun enters Cancer. I mean,
Yeah. Yes.
no,
So
that's
that
not an
means
expression that I'm familiar with. Yeah, go ahead.
okay. What's your star sign, Nachi?
What's my star sign?
Yeah, like I'm an Aries. I was born in
Oh,
April.
yeah. Okay, yeah. So I'm a Scorpio, according to Vedic astrology.
Okay, all right. So you know what that means, right? That means that the position of the sun inside a particular constellation. Okay, so for about a month, the sun will spend about a month in each constellation, and then it falls
Hmm.
behind. Okay, it falls behind. That's the whole star sign came about back in the Babylonian era. Okay, so the sun, here the sun enters Cancer, right? So what is this? Now there is an article here from the Astronomy magazine. When the sun enters a constellation, doesn't it make it impossible to see that constellation? So the person here says, I was reading on NASA's website about how the Babylonians came up with dividing the sky into different slices and picked a pattern of stars in each slice to represent it. This ties into astrological signs, and that being born under a sign means that that particular constellation is aligned with the continuation of an imaginary line from Earth to the sun. Right? So just to make short, but choose to observe merely a month earlier. Okay, so what that means, Nachi, is that during the day, the sun is traveling, circling around just like the stars are. But because the sun is shining, you cannot see that particular constellation. So to know where the sun is, you need to pay attention what comes before, what constellation is before and after. And then you know exactly where the sun is. So this is what they're explaining here. It's true that for an observer standing on Earth, the daytime sky blocks out our ability to see the stars, the exception that stars that are visible during the solar total eclipse. The point of the above post is that if we pick a specific location, for example, that spot in the sky between Scorpius, your star sign, and Sagittarius, you cannot see directly at that spot during the daytime, but choose to observe merely a month earlier or a month later, and you can see that spot either just prior to sunrise or just after sunset. Since ancient observers would certainly have been able to observe these constellations side by side during months when they are visible at night, it would have been easy to derive, based on the first visible constellation after sunset, or the last visible constellation prior to sunrise, where the sun is located on the current day, and to do this without needing to see the stars that beyond the sun's current location. So right now, the sun is when we first start talking in August, okay, the sun was in Leo. All right, this is Leo, the Leo constellation. Right now, as we are having this live stream, the sun is in Virgo. So how can that be? The sun must be rotating because the sun follows, it's within that constellation for the entire month and then falls back because the stars they go a little bit faster than the sun. So slowly the sun is left behind. And then for the whole month, the sun is going to stay in that constellation. So you told me you are a Scorpio, correct?
Yep. Yep.
So right now the sun is in Virgo, right here. So we cannot see this constellation at night. You go outside and now you won't be able to see because the sun is right here. Okay, Scorpio is right here. So what will happen is you can see Scorpio now, and for about 2 or 3 months, the sun will be in Scorpio, and then we won't be able to see it anymore. So that alone, Nachi, shows that we have a circling sun because they have to, if the stars are circling like we just saw along Polaris, we have to have a circling sun. Now, this is a quote from the book of Revelation. The book of Revelation was written in the first century, like 2,000 years ago. And this guy called Apostle John, he was in Greece, and he looked at the sky and he recorded what he saw. And there appeared a great wonder in heaven, a woman clothed with the sun and the moon under her feet, and upon her head a crown of 12 stars, and she being with the child cried, travailing in birth and pained to be delivered. So we know for sure that there was daytime when he looked at the sky because he saw the sun. So he knew what constellation was behind or in front of the sun. I don't know. And he knew exactly what he was talking about. If he had had that vision at nighttime, the sun would not be in Virgo because you cannot see a constellation if the sun is there. So this was recorded. He looked at the sky and said, okay, that's where the Virgo is, the constellation, the sun's there, the moon's at her feet, and he described it. Okay, and that's what he saw. Okay, Leo, Virgo, that's the vision he had. So this proves that for about a month, the sun will travel. It's gonna hide that constellation. Okay, for about a month. It has to circle, Nachi. There's no other way. Because if the sun is not circling, it cannot hide the constellation, the stars that are circling around this flat Earth. Okay?
Yeah.
This is the star signs according to the Chinese. This is according to the Japanese. They all observe the same thing. You have the yin yang here. And just want to quickly move to the part, this part right here. Okay, so what happens? Like I had a big argument with Jake Gibson, like 6, 7 years ago over that. He watched a presentation by a guy called Nesbitt. I don't know his name. He's a British guy. And then he starts saying, okay, the sun does not circle the flat earth because on the meridian, the Greenwich meridian, everybody observes the sun rising 90 degrees and setting to 70. Okay, all right. That's his observation. All right. But what I find, Nachi, pretty unfair is that they pick one longitudinal line, which is based on the polar projection, and they get their conclusion, right? But we don't have only one. You can divide this by 24, 36, 48, So here we have, Nachi, all right? Let's say this is the zero meridian. Everybody's observing the sun rising 90 degrees angle on the equinox, correct? Would you agree with me with this?
Yes, I'm in agreement so far. Yes.
Okay, but remember, they chose this arbitrarily, which is based on the polar projection. All right.
Okay.
Now, what do you think would happen if somebody is in this coordinates longitudinal line right here? What do you think would happen?
I imagine the same thing during the equinox.
All right. So
Right?
you would say something like this?
I would imagine. Yes.
Yeah. How about here in Rio, in Brazil, my home country? Would you say that they would observe something like this?
I would imagine during the equinox that it would have that would happen on all the longitudinal lines.
Exactly, right? And
Okay.
let's say
Yeah.
Buenos Aires, right there in Buenos Aires. You can talk to that guy in Buenos Aires, I forgot his name, Iru. That's what he observes in Buenos Aires. And we observe the same thing in Rio. And we observe the same thing in Africa. How about in Bogota, Colombia? Would you say they observe the same thing? Yes.
Okay.
So what
Yes.
do we have at the end of the day? Okay, everybody observes the same thing. And remember, the
Hmm.
sun is traveling with a particular constellation for the entire month. So we do have a certain sun. Now, what happens is most of the people who are trying to convince us we don't have, they just pick one longitudinal line. And they talk a lot about, well, we don't have just one. We have at least 24 or 36. You can divide the pie for as many slices as you want. Okay? That's what we observe. Now, we do have a guy, his name is Dr. Zach. He did this for 1 year. He made this observation and he put in the computer, and that's what he got. So the sun is everywhere. It rises 90 degrees for every one on this polar projection. Okay, that's what we have. So at the end of the day, the Japanese were correct. Okay, and so were the Chinese. All right, when the Japanese designed this model here, and they had a mechanical sun and moon circulating around the Mount Meru, they were right. I would say that the Japanese were right and Jake Gibson is wrong. That's my position, right? Now look, you observe the sun rising like in a straight line. Same thing, everybody will observe the same thing. Right? The sun will rise 90 degrees east and set 270 degrees west on the equinox. I made this real quick here, and that's I'm gonna end my presentation right here so we can go for some questions and answers. Okay, so here's the sun, the equinox, right? And you see as the sun rotates, right here, Nachi, the sun is in, I think, in Libra, right? Right there in Libra. Okay, at the equator, this is the equinox. And remember, if the sun is in Libra, the sun will be in Libra for the entire month. It has to be rotating to hide this constellation. There's no other way. And then I'm going to rotate it right now. You're going to see how so there you have it, because the sun is in Libra. It's hiding the constellation for an entire month. So the sun, there's no other way. The sun has to be circling the flat Earth. There's no other way. You cannot have. If you say I'm an Scorpio, you telling me that when you were born, the sun was positioned in Scorpio and was hiding that constellation for the entire month. When I tell you I'm an Aries, that's where the sun was for the entire month. You know? So that's my evidence to you, okay, that the sun does circle the flat earth. There's no other way. And that's, it's not a physical sun, probably, but everybody observes the same thing. And that's the vision that Apostle John had in that first century. The woman was clothed with the sun, the moon was at her feet, and she had 12 crowns, which means the constellation of Leo, right?
Don't waste any more time. Visit the links above now and order my book 16 Emergency Landings Proving Flat Earth. Visit my online store now and order the new enhanced Gleason's Flat Earth map. This map used to be in every school and library in the nation before NASA was created in 1958, when the maps were ordered removed. Have your Gleason's map hanging on the wall in your house where no government can take it down. Here you see it hanging on a wall in the house of the late Charles K. Johnson. Here is a quote from the book 1984 by George Orwell. Every record has been destroyed or falsified, every book rewritten, every picture has been repainted, every statue and street building has been renamed, every date has been altered, and the process is continuing day by day and minute by minute. History has stopped. Order your map now.